Better record this. So here are the steps when solving radical equations. Every time you do this exact same thing, no matter what. First, isolate the radical completely. Get the radical completely by itself. Nothing multiplied to the radical, nothing added to the radical. Second, undo the radical using the correct inverse. So inverses undo each other. That's how we solve all types of equations. So we'll undo the radical using the correct inverse. So like what undoes a square root? A square. Correct, everybody? You get what I'm saying? And then third, once we've undone the radical, got rid of the radical, then we just use algebra to solve for the variable left over. So then it's just using algebra to get x alone once you undo the radical. Now understand, we're going to be taking and manipulating these equations so much. Once again, it could introduce extraneous solutions. There's going to be tons of extraneous solutions in this one. You'll see it on the worksheet. You'll see it on your test. So this is when you'll run into extraneous solutions. So solving a square root equation, you may be required to square both sides of the equation. Square both sides. If that happens, then it can introduce extraneous solutions because now we have a quadratic. Does that make sense? And so quadratics have two solutions, correct? So you've got to check all your answers, always. All right, let's just start practicing. I love this because it's straightforward. These steps work for all solving, but it will test your algebra skills. So, first thing we do is isolate the radical. Isn't this our radical? Isn't this our radical? Yeah. So get it all by itself, using correct algebra in the correct order. What should I do first? Good, subtract 2 from both sides of the equation. So we have 5. Square roots of x is equal to 10. Now what would I do? Would I square both sides at this point? No, you got to isolate the radical completely. My next step will be to divide both sides by 5. Very good. So we have the square root of x is equal to 2. Now we've isolated the radical. We need to undo the radical using the correct inverse. What undoes the square root? Square. So we're going to square both sides of the equation. Now on this side, root and power cancel out, or they undo each other. So we have x is equal to 2 squared, which is 4. Our solution's 4. Let's check it. 5 times the square root of 4 plus 2 equals 12. Is that a true statement? 5 times 2 plus 2 equals 12. 10 plus 2 equals 12. 12 equals 12. Check. So that is our solution, not extraneous. Everybody feeling good? Pretty easy, right? So number 4. No, the same rules apply. Isolate the radical. Isn't my radical isolated in this one? Now we undo the radical using the correct inverse. What undoes the square root? Square. So we'll square both sides of the equation. Root and power undo each other. They cancel out. We have 2x minus 5 equals 49, correct? Now solve for x just using algebra. So we'd add 5. And then we would divide by 2, right? It's that simple. What do we get? And we will check our answers. So we have the square root of 2 times 27 minus 5 equals 7. We're plugging it back into the original, correct, everybody? So we have the square root of what? What's 2 times 27? 54 minus 5, which equals 7. Square root of 49 equals 7, 7 equals 7, that is true, so that is our solution. Pretty straightforward. So the first ones are very straightforward. So on 5, let's not go through it, I'll let you just practice it, but what would you do first? Add 6, then you'd square both sides, right? Pretty simple. What about this one? What would we do? Add 4, cube both sides, okay? And then go ahead and do 1 through 12. Ready, set, go. Let's look at these ones. So I want you to look at, I'm going to solve this 2 different ways. Okay, so look up here. Guys, this is really important. So notice I'm trying to solve for x, correct? Don't we know, we just learned that rational exponents are really radicals, correct? Yeah. Everybody? So couldn't I rewrite this as the cube root of x minus 2 to the first power equals 5? And now couldn't we just solve like we just were solving a second ago? We could rewrite it. That's absolutely great. That's one way of doing it. However, so let's think of it a little bit more advancedly. We're doing the same thing algebraically, but let's think advancedly about this. Isn't this, so our first step is isolate the radical. That's all underneath the root, correct? Yeah, so now can't we raise both sides to the third power? Because then raise the power to a power and you multiply. Won't that become x minus 2 to the 3 over 3, which is really x minus 2 to the first, which equals 5 cubed, right? Which is what we're going to do anyways, cube both sides. Does everybody see how you could just do it without rewriting it? Okay, so then we continue to solve that. So on 13, we could continue to solve that. So, no, 50. So, next one, 15. We could solve this one 2 different ways. This is the same thing as 2 times the 4th root of x cubed, correct? Equals 16. So our first step would be to do what? Isolate the radical. So what should I do very first? Divide by 2. So we have the 4th root of x cubed equals 8. So then undo the 4th root. You'd raise both sides to the 4th power. So then root cancels out with power. So we have x cubed is equal to 8 to the 4th. And we could calculate that. And then what would we do next? Cube root both sides of the equation, right? Okay, that's one way of doing it. Or I would, a little bit more advancedly, much quicker. Wouldn't we first need to isolate the radical? So we would first divide by 2. We've got to do that no matter what. But now, let's undo this without rewriting it. What would I raise both sides to make that a 1? 4/3, right? 12 over 12, the reciprocal. Won't that undo it? So we got to do that to both sides, 4/3. So now that becomes x to the first, so we're good. And then you'll do 8 to the 4/3. And you can think of that 2 different ways. You could rewrite it as the cube root of 8 to the 4th, or you could use your calculator. If it comes out a decimal, though, then you have to go back and rewrite it and do it by hand. Does that make sense, everybody? If it comes out evenly, you can just type into your calculator 8 raised to the 4/3. 16. Okay. Okay. All right. So we still have a minute. Okay, so let's look at 18. You guys solve 18. Ready, set, go. Do 18. Okay, that is correct. So the first thing you did was add 5. So you have 4x raised to the 3/2 is equal to 108. Then you did what? Divide by 4. What is that? So x to the 3/2 equals 27. Then what did you do? Raise both sides to the 2/3, which will help us because then it's a 1. 2/3. Okay. So then you have x is equal to, technically that's the cube root of 27 to the 2nd power. So you could simplify it that way, or you could type it in. Now there is one thing I want you to notice about all the examples we just did. Okay, I'm going to highlight something. When we got down to the last step and we were going to solve, it was a cube root. Isn't that an odd root? So isn't there only one answer when you take the cube root? Look at this example. Didn't we get down to a cube root? Then we got down to a cube root, so that was an odd root. What about here? Wasn't it also an odd root? So don't we know that when solving and we take an even root, like a square root, we have to account for the plus and minus? So we haven't had to do that yet, but we will. So problem 23, for example. Let's go through and solve that. That's one of the most missed things on the test. So we're going to solve using the same way. We just got to remember when you deal with an even root and solving, you have to account for the plus and minus. So our first thing we would do is add 4. So So we have x minus 2 raised to the 2/3 equals 9, correct? Now we'll undo that 2/3 power by raising both sides to the 3/2. Because then we get a 1. So we have x minus 2 to the first power, which is really just x minus 2, is equal to. Now look, if we were to rewrite this, this is the same thing as the square root of 9 to the 3rd power. Don't square roots have plus and minus answers when solving, right? So we're going to have to put plus and minus right here. So type into your calculator 9 raised to the 3/2. If it comes out even, then you're good. If it comes out a decimal, we would go back to here and plot groups of 2. Ish. Plus or minus what? Well, let's see, is it? 9 and 9 and 9. 9 times 3, correct? So 27. This is what we're looking at. You forget the plus and minus when dealing with an even root. Roots are on bottom. Even roots have to have plus and minus. So now split it apart. We're going to have two answers here. We have x minus 2 equals positive 27. We have x minus 2 equals negative 27. Solve for x. Add 2. So x is equal to 29. We'll add 2. X is equal to negative 25. So now we would check both of those by plugging them both back into the original, and if they both work, they both are solutions. If one works, the one's a solution. If they both don't work, they're both extraneous, you'd say no solution. Does everybody understand? Yeah. Okay, sweet. So those ones both work, and once again, you plug it back into the original. Do I need to go through how to plug those in, or do you feel good about that? Plugging them back into the original and calculating it? Okay, so you guys do 24. And then that'll be it till lunch, and then we'll come back and keep going. X is equal to 8 and negative 8. We all got there? Okay, you guys can go to lunch. You have to be, guys, I'm telling you, please, I'm asking you to be very smart and use your brains and think. And don't do things you know you can't do. So think when you go through these. So we're solving this radical. The first thing you do is isolate the radical. Isn't the radical isolated? Nothing added, nothing multiplied to the radical. Okay, now we're going to undo the radical. So how do we undo a square root? Square both sides of the equation. So I need to put this in parentheses squared, right? So over here, root cancels out with power, leaving us with x plus 1 is equal to. Can I just square that and square that? No. So we would need to, now keep in mind, our goal is to solve. So we would want to actually multiply this out here so that we know what we're looking at. So really, right now, what we have is x plus 1 equals x squared minus 2x plus 1. So you say to yourself, how do I solve this? It's a quadratic, right? Don't we need quadratic set equal to 0 to solve a quadratic? Yes, so let's get this side equal to 0. Using algebra, though, from this point, so I'm going to subtract x and at the same time subtract 1. Won't that make this side 0? So subtract x, subtract 1. So over here on this side, that's 0 is equal to, we have x squared, combined like terms, minus 3x, and then those happen to be 0, correct? So you say to yourself, how do I solve this particular quadratic? There are many methods. I solve by factoring if possible. Can't this factor? This one's an easy one. Don't we factor out an x? Yeah. And then left is x minus 3. So we have this. Now we know that solving a quadratic, once you have it factored, you can set each of them equal to 0 and solve. So we get x equals 0 is a solution. We'd add 3. We get x is equal to 3 as a solution. Now didn't we square both sides of the equation? So we need to check for sure to see if there's extraneous solutions, because that's where they're introduced, is because all of a sudden we have this quadratic. So, all right, let's check it. So go back to the original problem. I'm going to check for x equals 0. Plug it in. We have the square root of 0 plus 1. Does that equal parentheses 0 minus 1, right? Isn't that the original problem? I don't even need parentheses. Yeah? Is that the original? Yes? Yes. So we have the square root of 1 equals negative 1. 1 equals negative 1. Is that true? No. So that is extraneous. It was a product. It was a solution of the new quadratic, the new polynomial, but not the original. That's an extraneous solution. No, remember the square root of 1 when simplifying is just 1. good question. Only when solving do we need plus and minus. Does that make sense to everybody? Okay, so square root of 1 is 1. Okay, now let's check for x equals 3. Do the square root of 3 plus 1, does that equal 3 minus 1? So that's the square root of 4 equals 2. 2 equals 2. So that one truly was a solution because that's a true statement. So we throw this one out. It's extraneous. I like to see it written and crossed out because then I know you found them correctly and then you checked them correctly. So x equals 3 is the only solution. Everybody feeling good about that? Okay, so do you see it? Okay, so algebra-wise. 31, how would I do this? What would you do to this? To solve it? What would be your first step? Like, square both sides. Way to go, this group. This is technically the square root, correct? And we know that this is, we've got to isolate our radical, so it's isolated. So we square both sides of the equation. So go ahead and finish that one up. How many of you got this as your solutions? Then when you checked it, what did you get? What was your final answer? X equals 9, 2 is extraneous. All right, good. Let's move on to the next one. Number 40. No, nope, it's just crossed out. Like that's not a solution. Okay, so number 40, looking at this one, what would you do? First step. Add 1, let's do that. So we had 2 fifth roots of 5x plus 2 equals 4. Then what would you do next? I like it. Divide by 2. You're absolutely right. Isolate the radical. The fifth root of 5x plus 2 equals 2. Then what would you do? Fifth power, right? Fifth power it. And then you continue to simplify. Everybody good with that one?
128 now. 128.
So we have 5x plus 2 equals with 2 to the 5th.
Right there.
And then we have subtract 2, subtract 2. So we have 5x equals 30. Divide by 5, x equals 6. We would check it. So we're all good. Do you guys know how to type in the fifth root into your calculator?
No.
You want to learn? Okay, pull up your calculator. I want to show this in the video. So, wow, don't look. Okay. Okay, so this is how you do it. So you'll hit, in here, you go like this. Okay, so you hit 5 to tell it you want to be fifth root in a minute. And you go to math, down to xth root. Right there. So now it knows that it's a fifth root. Does that make sense, everybody? Math, and then down to xth root. So now you can do any root on your calculator. Oh, yeah. I like what Amelia's thinking of. She's saying you could just literally type in that raised to the 1/5 power. That's a smart way of thinking about it. Good job, Amelia. All right, let's look at 42. This one's an easy one. Watch what happens. Your first step. First of all, you can do this the easy way or the hard way. Here's the easy way. Isolate the radical. So there's 2 radicals. So put one radical on one side, the other radical on the other. But you got to use correct algebra. So we'd add the square root of 5x plus 2 to both sides. So right now we have the square root of 7x minus 6 equals the square root of 5x plus 2. Isn't that pretty easy? The roots are isolated, then we would square both sides. Well, in this problem, didn't root cancel out with power? And on this side, didn't root cancel out with power? So did that make it like one of the easiest problems we've done so far? You know what I mean? So then we could keep solving, subtract 5x to combine our x's. So that's 2x minus 6 equals 2. We'd add 6. So we have 2x equals 8, divided by 2, x is equal to 4. We would check it by plugging it back in to the original problem, and we are good. 42 is x equals 4. Okay. What about this one? What would you do? This is one where people mess up the algebra big time. What would you do? Square both sides. I like that idea. Both of you are having the same idea. Now careful, isn't this on a side? So when I square, let me show you where people mess up. Over here, don't you have 2 squared and that squared? You see, that's where people mess up. So we have 2 squared, which is 4, and then we have x minus 1 now. We're all good with that? And then over here, we do have 26 plus x, because the root cancels out the power, but people forget that that 2 had to also be squared. Does that make sense, everybody? So now we can solve this 2 different ways. I'm just going to distribute 4 through. So we have 4x minus 4 equals 26 plus x. Then solving for x is quite simple. Subtract x. So we have 3x minus 4 equals 26. I swear I was doing this right. 43, okay. Add, yeah, perfect. So 3x equals 30. So x equals 10. And then we would check it. Everybody good? So don't make little errors, which you guys saw that pretty quickly. Okay, this one is a tricky one. Let's see, what would you suppose? If you're wrong, it doesn't matter. This is why we're doing this. What do you think we should do? Yes, good. Yes, Keelan has the right idea. Let's get this over to one side of the equation. Isolate the radical. So let's add 2x plus 1 raised to the 1/4 to both sides. Add 2x plus 1 raised to the 1/4 to both sides. So we have x minus 1 raised to the 1/2 equals 2x plus 1 to the 1/4. Now, what are you thinking from here? You fourth both sides? I heard someone say over here. Were you saying that? Oh. Okay, yeah, there's a couple of different ways we could think about doing this. So you're saying you can make this 1/4. How would we do that? When you multiply the same base, you would add your exponents, right? So that's one way of doing it. You have an x minus 1 to the 1/2. No, that's not how it works. So how would we do that? You could multiply by 2, but you got to do that for both sides of the equation. So then that would give us 1/2 over, you know what I mean? So those are good ideas, but just not, I mean, it's a good idea, just we're making it, it's still not helping us quite enough, because if we raise it to the 1/4, then that makes that 1/16. Does that make sense?
Yeah.
You have to do it to both sides evenly. So I heard these guys say let's raise it both to the 4th power. I like that because it gets rid of our biggest root. So that's what I'm going to go with. So everybody watch what happens. 4th power, raise it to the 4th power. So that takes care of that side, but let's look, what does this side become? X minus 1, what? Squared. Okay, that's not bad though. And then we have over here just 2x plus 1. And now isn't it just a quadratic that needs to be solved like before? So we got rid of the highest root. Yes. No, I mean, no, technically no. You'd want to bring it over and then do it. If you're going to raise, but if you raise both sides to the 1/2, then that fixes this to become 1/4, but now it's 1/8. Does that make sense? Okay. Okay, so then we can keep solving the quadratic. Okay, looking at this one, we would isolate the radical. There's a couple different ways we could solve this. I would add the square root of x plus 1 to both sides. Add the square root of x plus 1. Now watch, because this is where a lot of people make errors. So we have the square root of 2x equals, I could have probably done this easier, but the square root of x plus 1. Okay, is everybody up to here, up to speed? So then we would have to square both sides, right? Square, oh, I got to put this in parentheses, squared. Now, root cancel out with power. We have 2x is equal to, is it appropriate to square that, square that? That's breaking the forbidden rule, guys. If there's an addition sign, you can't just square both terms, right? Don't we know that something squared means that times itself? Does everybody see where algebra could get messed up here? Okay, so we would have to write it out as 1 plus the square root of x plus 1 times 1 plus the square root of x plus 1. And now we'll double distribute and combine like terms here. So I probably should have brought that over because that would have been much smaller. You know what I mean? Multiplying out the square root of 2x. But since I'm this far, let's just keep going with it. 1 times 1 is 1, right? This one's kind of advanced. 1 times that is that, so plus the square root of x plus 1. And then that times 1 is itself, so we have plus the square root of x plus 1, right? And then don't we have times the positive square root of x plus 1 squared? We have it twice. So root cancels out with power, right? On that piece. So over here, I'm just going to keep simplifying this side. We have 1 plus 2 square roots of x plus 1, which we are combining like terms, right? Does that throw anyone off too much? And then we have plus x plus 1. That's equal to 2x. So now don't we just have another radical we need to isolate and solve? Does everybody get what I'm saying? Okay, so let's isolate the radical. So let's bring that over. Subtract x, subtract 1, subtract 1. So that 2 is connected by multiplication. So we have 2x minus x on the left now because we're doing that to both sides. So combining my terms over here, that's 1x minus 2. Am I correct? Equals, watch my algebra because I make errors too, the square root of x plus 1. Is that everybody good? Divided by 2. So this is one of those problems that I solved the hardest way possible because I should have brought this over because that would have been a lot quicker. But we're almost done, I'm just saying. This is one of those times when I say there are right ways and wrong ways. We've done it right, but the longest way. So right now we have x minus 2 over 2 equals the square root of x plus 1. So we would square both sides, right? So, yikes. So, I did this the hardest way possible. I'm so annoyed with myself. So let's go like this. X minus 2 squared over 4. Is everybody okay with that? And then that's equal to x plus 1. So we do need to keep going though. So this is x squared minus 4x plus 4 all over 4, which equals x plus 1. So I don't like this. Now it's going to be solving the quadratic with fractions, which I don't like because we could say this is 1/4 x squared minus x, because I'm dividing them individually by 4, equals x plus 1. So we have 1/4 x squared. I'm going to show you how I'm going to fix it for myself. We have 1/4 x squared minus x though, right? So minus 2x minus 1. Oh, this one's not too bad. This one's not too bad. We're almost done. Minus 1, which is 0. So isn't this our equation? And now we'll just factor out an x. And left is 1/4 x minus 2. Now we'll solve. X equals 0. Solve for x over here. Guys, 1/4 x equals 2 times by 4. X equals 8. We did that the hardest way possible, but we got the right answer. Okay. Okay. Then one of those is extraneous. Not always, but sometimes I believe, let's see, 45. X equals 0 is extraneous, so we throw that one out. Everybody good with that? Okay, so do 29 to 50 right